Good morning, class. So once again, we're going to continue our discussion on the introduction to multiple linear regression. Okay, sorry for the date here. Yung date, ginawa ko yung generic. Okay, so quick review lang, guys. But before we do that, let me just, once in a while, I'm going to interject some R markdown skills. If I open an R markdown, okay, R markdown, I'm going to open one, new one. Okay, I'm not going to open a document. What I'm going to do is I'm going to open a template. Okay, I have several templates here. We will have different templates because I have already downloaded certain packages that that bring with it some templates. For example, there's this one by Tufte. So let me choose this Tufte handout. Okay, okay. All right. So this is an R markdown using the Tufte theme. Okay. If you notice, there are in the YAML there are several chunk codes here. Tufte HTML from the Tufte package, Tufte handout, citation package, for bibliography, okay, also for book, okay, link citations, yes. All right, so if I go through this, just like our markdown, guys, this is the sample, no? So may sample din si Tufte dito. Okay, so we will not go into the nitty-gritty details of this, yung mga chunk of codes niya. But let me just show you if I need this. I'm going to need this, need it to Tufte HTML. Okay. You can see that it can be knitted into a handout or a book because here in the YAML, diba? Pwedeng HTML, pwedeng handout, okay, pwedeng book. Okay, and let me just knit it to a Tufte HTML. Then ipapasave ulit yan. Just Tufte trial. Okay. Save. Nasaan ba ito? Okay. Dito sa FINTSARK natin. Okay. Tufte trial. Save. So mag-minute na naman siya, guys. So let's wait for it to knit. Okay, what I'm doing now is I'm giving an illustration of other functionalities in R markdown. So far, what we have learned was just the regular R markdown, no? And R markdown has several features, and incorporated with it are certain templates from packages like the Tufte package. If you want, you can download, you can install the Tufte package now. So you know how to install it, guys, no? So, okay, took some time. Okay, so it's now processing, it's now knitting. In a few seconds, we should be seeing the output, guys, the HTML output in the viewer. Okay. So guys, no? Ito yung output ng document. And you can see here that may mga side siya, no? May mga side comments dito. Okay, may mga side comments siya. right? So you can notice that the page itself is divided into, pwede kang maglagay dito ng bibliography, ng footnote on the side. And then you can put plots here also on the side instead of having it below. Diba? Ito yung empty cars to, diba? Okay, so ito, pina-plot lang yung colored by automatic transmission and automatic sa manual. No? We're plotting here yung empty cars, yung HP on the x-axis, horsepower, and the miles per gallon. Ito yung ggplot na code niya. Okay, and you can also put a mathematical equation, ito. Or even occupy the whole row for your plot. So, pwede rin yan. Pwede rin dito. No? Okay, so this is an example of, and magaganda yung mga font niya. No? May side margin siya, may side note, may margin note. Okay, and you can see here, ang ganda ng table. No? Meron pwede yung mga black coats like this. Okay, and so on. Right, so I just wanted to show to you that there are many templates that you can use. Example ito si Tufte, which I like. Gusto ko yung template ni Tufte. Okay, and you can do this, guys. You recall how I did this? Let me just summarize how I did this. First, you have to install the package Tufte. So, you know how to install packages, right? Install the packages. Install the packages to Tufte and then library Tufte. And then you create a new R Markdown. I'm just summarizing it, guys. And then do not choose document, choose from template. When you choose from template, ito na yung mga sample templates. No? This came from this particular package. So yung kay Tufte, may Chinese version pa nga siya. Okay. Nandun kay Zarin dyan, Ninja presentation. Okay, so anyway, I just want to insert this tidbits on our Markdown. Okay, so let's go back to our lesson, guys, on multiple regression. We said that multiple regression, it's all about explaining a particular variables, a variable of interest using explanatory variables. Okay, so we use explanatory variables which are otherwise known as independent variables, predictor variables, in order to describe and to find a relationship with the response variable or dependent variable. Okay, so the goal is to be able to first describe and also to predict. So given your independent variables, can we use those independent variables in order to describe your dependent variable? So we're assuming that is there a relationship between them? And if there is, then are we able to predict? Because that's one function, that's one important function that we need to predict the dependent variable. And we discussed the equation last time. We said that this is the general equation for a regression line where your response variable y is explained by your several response variables or independent variables. Okay, and the difference between the predicted value and the actual value is defined by your error term, by your residual. Okay, so there are certain assumptions as far as regards multiple linear regression. First is the linearity of the data. Okay, that's very important. it means that the relationship between your x and y, the response variable and your predictor variable should be linear. Okay, so I guess I didn't put it here, but hindi pala ako nag-example dito. Okay, so anyway, let me see if it's here. Let me open. I just want to show you some. I have a figure here. Wala yata. Okay, so ito na lang. So, I'm opening another file. This is a file that I use for some masters. Okay, so just to illustrate this, okay. Maybe I should. Can you see, guys? If you can, I'll put this in the chat box. Can you copy this, guys, and put it in a code chunk? I just want to show you something. And if you are able to do so, guys, kindly, kindly chat yes para alam ko, guys, na ano. So kindly copy that. Let me just explain to you. Let me just illustrate to you very quickly yung sa linearity of the data. And another one. So put it into separate code chunks. So let me just were we able to copy this, guys? Okay, kindly chat, please, if you were able to copy the two sets of, put it in two separate code chunks. Okay, sa chat box na lang. Thank you. Thank you. Okay, how about the rest, guys? Were you able to copy it? Okay, thank you. Only 3 responses. Any additional responses, guys? Okay, let's wait for your classmates to copy this lines of code in a code chunk. About the rest? Okay, good. Thank you. Thank you, guys. No? Although, parang ang konti lang nag-respond. No? Okay, so first, let's create an object called quadratic. And then it's a function. No? Take a look at this, quadratic function. So this is a special type of function. Just like when we created a list, recall, guys, or when we create a vector, we use concatenate, see? A function is an object also. So here we're defining 4 parameters, x, a, b, c, and then return. So this is, in other words, to generate this output, a times x squared plus b times x plus c, which is the it's the equation of a it's the equation of a quadratic function, ba? X squared, ax squared plus bx plus c. Okay, so let's run this first. This object, control enter. Okay, and then you will see here now. So this is another type of data. Data. This is for lists or for data frames. Values are for vectors. Okay, and then here we have another type of object, type of data structure, which is a function, and the name of the function is quadratic. Okay, and when you define what are x, a, b, c, then you'll be able to generate an answer. Okay, so let's see. If we define a to be 1, b to be -2, and c to be -3, 4, -4, and then define your x. Here we're defining x to be a sequence from -3 to 3, and the length is 100. So it will generate 100 numbers, continuous numbers from -3 to 3. And then if we now run this function quadratic x a b c, then it will generate a value. Okay, so first let's make sure that we have run. Let's run this a b c d. Okay, so we have now here in our values a b c, and then we have also x. So if I print x, let me just print it here, x. Okay, so you notice, guys, x is a vector of numbers from -3 to 3. Diba? -3 hanggang 3. Kasi nagpa-sequence tayo. Sequence from -3, this one, from -3 to 3, and the length is 100. So we have 100 observations here. So x is a vector, okay? Vector of numbers, and we should have the same, guys. Kasi pareho yung parameter natin from -3 to 3. Okay? And then, if we choose to run this quadratic x a b c d, x a b c, then what will happen is that R will substitute yung mga numbers na to, yung a, b, c, into this function called quadratic. So papalitan niya yung x from -3, diba? From -3, tapos papalitan niyo si ABC. So that's one output, di ba? Tapos ito naman -2.9393, that's another output. So there will be 100 outputs for this. So if you run this, yun. And so this is the answer, 100 then. 100 for this function a times x squared plus bx plus c. Okay? All right, any questions about the object, the structure called function? Maraming gamit, guys, yung function. No? In fact, guys, yung mga packages, ginagamit nila yan. For example, how to compute for, let's say, a particular value. And then that value is defined by a mathematical equation. So, yung mga packages, linalagay nila sa code yan in order to generate, for example, whatever, mean, median, whatever, guys. Okay, using a particular function. Di ba pag nagmi-mean tayo, di ba? Mean ng x. Okay? Paano na-compute itong mean ng x? Kasi at the back of this, guys, is a code. The code for the function mean. So this mean is a function, guys. And it was generated by this one. Parang function na ganito. No? So that when we use mean, which was predefined, okay, we get the mean of x. Yeah, we were able to get it, the average of x. What can we get? Ano ba yung x natin? Why is this so small? Mean of x. Ang x natin from -3 to 3, length of 100. What did you get, guys, for your mean of x? Kasi what am I getting a very, very small number. Did you get this, guys? Feedback na, please. When you generated the mean of x, ito yung x natin, di ba? A number from -3 up to, wait. Quadratic pala ito. -3 to 3, di ba? Right. So if you get the, yes, sorry. Yes, that's correct. No? Kasi from -3 to 3 siya, no? -3 to 3. So ang average must be practically 0. No? Yeah, correct. This is correct. Sorry, I got confused. No? That's 0. All right. So yung second, guys, yung second na sinare ko sa inyo, it's this time we're creating another object called x. So it will supersede the object that we just created, and it's a sequence from -10 to 10, and let's use 1,000 numbers. So we're going to plot x and the quadratic of x. Take note of this. Ito, no? Quadratic of x, which is a function, di ba? And R will recognize this because we have this object which is a function which resides in the memory, no, of R. So ipa-plot natin on the x-axis is your object x, which is this one, and then yung y natin yung value ng quadratic, and then let's use type is equal to L, and then dito may idadagdag tayo dito, guys, horizontal line h is equal to 50, color is equal to blue, and then the length of grid is equal to 2. So let's run this. Let's run this, guys, and then we have this. Okay. Just okay. Now, sorry for this long example. My point is, guys, here, this is linked to the linearity of the data. If you have a relationship between your x and y that behaves like this, quadratic siya, it makes no sense, guys, to use linear regression for this one. Okay? Hindi siya magandang linear regression. Okay, there will be a lot of errors in this model. Okay? Only a small percentage would be explained by your model. So the point is, guys, you have to visualize the data first and take a look at the how the data behaves in relation to your x and your y, to your independent variable and your dependent variable. If your data behaves this way, then it makes no sense to use a linear regression model to explain your explanatory variable y. Okay, so your predictor, your response variable y, or your outcome variable y. It makes no sense. Okay, of course, there are certain things that you can do out of this. You can do transformation, like you can do log transformation in order to make it more linear, okay, which we will be discussing in the future. Okay, but again, guys, very important yung first assumption natin of linearity, linearity of the data. Okay. Second, guys, yung second assumption is, what's our second assumption? Our second assumption is linearity of the parameters. So let me just see if I can show you. Linearity of parameters, let me see. Yeah, here. Okay, pag linear in parameters, guys, sabi natin, the parameters should not take a form other than a linear form. Ibig sabihin, hindi siya naka-square root, hindi siya naka-log, hindi siya naka-cube root, hindi siya naka 1 over x, hindi siya pwedeng 1 over beta, because it will be very difficult to determine the value of your parameter if it's not linear. Okay? So for example, ito, guys. Pag sinabi natin linearity in parameters, independent variable, pwede siya. It can take on any structural form. It can be naka-square root siya, pwede siyang naka-log, pwede siyang naka-x squared, pwede siyang product, x1 times x2, pwede yun. Okay? Pero hindi pa pwede yung beta 1 times beta 2. Hindi pa pwede yung beta 1 squared, hindi pa pwede yung beta 2 square root. No? Hindi pa pwede. So if you have an equation that involves the square root of your beta, then multiple linear regression will not work in that. No? Hindi pa pwede. Assumption yung dapat na there should be linearity in parameters. Okay, by the way, yung linear relationship, let me just show this. Okay. So ito guys, let's take a look at the relationship between your y and your x. Okay, could you say that there's a linearity of the data here? Okay, pwede na rin, no? Medyo may linearity yung data. Pero kapag medyo polynomial siya guys, polynomial na maraming ups and downs, maraming minima and maxima, tapos quadratic siya, okay, or cubic function, then it's not good. Okay? It's not good to use a multiple linear regression if the relationship between the two variables is definitely or is obviously not linear. Ito pwede pa, no? Pwede pang linear yan. Okay, what was the third assumption, guys? Ano yung third assumption natin? Aside from linearity of the data, linearity in the parameters, third assumption was a homogeneity, no, of the residuals. When you do linear regression, guys, nag-generate talaga ng residuals. Kasi pinipredict natin yung value ni y using the estimated parameters, and then we compare it with the actual value of y. So there will be a discrepancy. If there's a discrepancy, which is almost always the case, then we have residuals. Tapos pag pinat natin yung residuals, guys, dapat yung behavior ng residuals, it should be constant variance. Pag sinabi natin constant variance, when we take a look at your residuals across several values of your residuals, guys, then dapat hindi walang trend, okay, or walang fanning out. So let me just show that to you. For example, okay, I'm sorry I'm using this lang kasi hindi ko na-need yung document. Pag ni-need ko sana, then automatically makikita natin. No? Okay, here guys is heteroscedastic residuals. No? Bakit? Kasi if you take a look at this point, guys, okay, ang level ng variation natin is from here to here. But if you go here, okay, what do we notice, guys? Tumaas yung level ng tumaas yung variation natin. Ganun din dito, no? Okay, from here at this level, ito yung variation ng natin, ng residuals natin. But at this point, okay, maliit na lang. So hindi constant yung variance natin. Ito guys yung constant variance. Okay, this is constant variance. So another assumption of your regression is that the residual should be constant, or what we call homoscedastic. So kung hindi constant yung variance, it's called heteroscedastic, and we don't want that. Ayaw natin ang heteroscedastic yung residuals natin. Fourthly, guys, okay, yung collinearity, no? Yung we call it multi-collinearity. Magkakaroon tayo ng problema kapag if our independent variables are collinear, especially if there's a strong correlation between them, because they will now share in the explanation of your response variable. So how do we now disentangle them? Anong effect ba ang binibigyan nitong isa? Anong effect ang binibigyan ng isang variable? Let me see if I have an explanation for that. Okay. I'm going to send again another file, no, na andun yung mga diagrams para makatulong sa atin. Okay, let me see. Hindi ko yata na-click yan. Okay, let me see this. Okay. So ito guys, this is a plot where this is your dependent variable removal. Okay. And then this is OD and ID. If you take a look at the relationship between removal and OD, here it's 0.91. Ito yung correlation nila. Now this is good. Ito yung gusto natin. We want that your removal, which is your dependent variable, be highly correlated to your independent variable, in this case OD. And then when we go here, so removal with ID, 0.79. Okay din yun, mataas. No? We want that your, as I said, your dependent variables to be highly correlated with your independent variable. But when you take a look at OD, guys, OD, okay, OD and ID, ito sila, no? OD and ID, you can either go down or you can go to the right. No? Okay, so OD, 0.88. Ayan. Ang relationship nila, guys, ang correlation nila is very high, 0.88. So we will have a problem with that. No? We will have a problem with that. Let me see if I was able to get the as an illustration. Dito ba siya? Okay, I hope I did. Yeah. Okay. Take a look at this, guys. This is the result of the regression. Okay, if you take a look at this, si OD, guys, ang ano niya, ang beta niya is 0.56, which means that for every 1 unit increase in your ID, OD, your removal increases by 1 unit. 0.55 units, I'm sorry, 0.56 units. Now, take a look at ID. Bakit sa ID, guys? Bakit insignificant? Di ba mataas yung ano niya? Di ba highly correlated to with highly correlated to with removal, dependent variable natin? Why is it that all of but siya naging insignificant dito, insignificant predictor? Yeah, precisely, guys, because may relationship si OD at saka si ID. So mag-aagawan sila ngayon sa pag-explain kay removal ng ating dependent variable. As shown here, 0.88. Okay, magkakaproblema tayo sa multicollinearity niyan. And there's a way to measure yung multicollinearity. We will study that, what we call the VIF, the variance inflation factor. Okay, so let's go back here, guys, to our lesson. Okay, multicollinearity, so we don't want that, guys. We want the the independent variables to be as uncorrelated as possible. So the problem with multicollinearity, guys, is that you will have coefficients that will be poorly estimated. It may be underflated or deflated or highly inflated. Okay, sometimes the coefficients might have signs that don't make sense. So, for example, it didn't happen lang sa atin, pero si ID, let me go back to that. I'm sorry if I keep on going back to these illustrations. Okay. Let me show you an example here. Let's assume, guys, na example lang for purposes of example, that this is statistically significant, that the p-value is less than 0.05. Now, in the correlation, di ba, si ID at saka si removal, highly correlated, positively correlated, di ba? Let me show that again. Positively correlated si variable, removal, at saka si ID. Yan, 0.79, 80, 0.8. That's a very high correlation coefficient. So it means that when removal increases, ID will also increase. Kasi positively correlated sila. However, when we take a look now at the regression coefficients, ang lumalabas dito, guys, kasi ID is negative now. Ibig sabihin, negatively correlated na siya with the removal. Pag tumaas si ID, bababa si removal. And that's ridiculous, di ba? Kasi yung plot, again, guys, sorry for going back to these plots. Tingnan niyo yung plot nila, oh. Yung plot, yan, oh, si removal at saka si ID ito. Di ba? Positive siya, positive correlation. So how can now your parameter beta be negative? Okay, and that's what happens, guys, because you have multicollinearity. So ito yun. The coefficients might have signs that don't make sense. Okay, and also the standard errors will be very high. So yan ang problem ng multicollinearity. Okay, number 5, guys, independence of residuals error terms. Dapat, guys, yung error terms should not be dependent with each other. And this is more an issue with what we call, sorry, did we discuss this last time, guys, yung cross-sectional time series at panel? Paki-chat naman, please. Did we discuss that? Hello, guys. Did we discuss yung cross-sectional data, time series data, at saka panel data?
Yes, sir.
Okay. So, as I was saying, guys, yung independence of residuals is more a problem with time series or panel series data, but not with cross-sectional data. Okay, and lastly, guys, yung normality of residuals. Okay. Now, itong assumptions na to, they should work in order for our estimates to be what we call blue. Ano yung blue, guys? It's called the best linear unbiased estimators. Okay? Best linear unbiased estimators. Okay. Blue estimators. Best linear unbiased estimators. And we strive this. Gusto natin, guys, na yung parameters natin blue. They should be unbiased. Okay? And when the assumptions are violated, then we might have issues with this. Okay? Pag hindi na linear yung relationship, then mawawala na to. Hindi na best, wala na yung linear kasi hindi naman linear yung relationship ng mga variables natin to your outcome variable. Eh, pag may heteroskedasticity, chances are bias yung mga estimators natin. So hindi na siya blue. Okay? So we seek a blue estimates, no? Gusto natin yung mga parameters natin should be the best linear unbiased estimators. And that will only happen when the assumptions of multiple linear regression are followed or are what's the term for that? They are, at the tip of my tongue. Yung assumptions ng linear regression are what's a good word for that? Sorry, medyo ano ako sa terms ngayon, no? Pag nasusunod, guys, yung terms ng ng assumptions ng multiple yung assumptions ng classical linear regression model, then there's a great chance that our estimators will be blue, the best linear unbiased estimator. Otherwise, guys, magkakaroon tayo ng problema dito sa estimators na gusto natin ma-achieve na blue siya. No? Okay, so we'll have more examples of this as we go to diagnostics. Kasi titingnan natin, guys, yung residuals. Once you have generated your regression model, we don't stop there. We have to look at ano ba yung natin, ano yung residuals natin. So, i-analyze natin yung residuals natin. Okay, so last time we looked at this, di ba? We looked at the did we guys check yung na-check ba natin, guys, ano natin yung mga yung sa descriptive statistics natin. I'm sorry, guys, I have to ask this question kasi sometimes I medyo I teach 2 subjects kasi na halos pareho, pero iba yung treatment dun sa master. Siyempre mas complicated, medyo highly mathematical din. So sometimes nami-mix up ko, no? I'm very sorry for that. Okay, so we looked at this, diba, last time?
Yes, sir.
Okay, so this is used for descriptive statistics. And in fact, I think you run, nag-run tayo, kunwari yung sa psych, diba sa psych, example lang. Anong ginamit natin sa psych package, guys? Anong function ang ginamit natin?
Describe po.
Yes, correct. So describe, na-generate na ba si empty? And then si wage. Describe si wage. Okay? And this will give us descriptive stat measures, mean, standard deviation. Okay? Of course, ito yung in-asterisk niya. These are categorical variables. Okay, so let me skip that because we have discussed that before. So I hope we have loaded yung wage data set natin. Just a quick look on our data set. Let's have just a quick review. Okay, thank you. Quick review on our data set, yung wage natin. Tatlo dito yung categorical, no? Education is numeric, experience is numeric, number of dependents. Okay, wala dun sa mga ano natin, tenure is also years to it. Number of years with the company. So these are all legitimate na mga numeric, no? Hindi siya yung pwedeng gawing factor. Okay, ito naman categorical, ano siya, yung categorical character variables, pero we can make them as factors. Kasi kailan natin ginagawang factor ang isang character variable? When we can use it as a classifier. Okay, kasi si white, pwede natin siyang gamitin na si race pala, pwede natin siyang gamitin na classifier whether white or non-white. Okay, later on we're going to, di ba, i-predict natin sa hourly wage using these parameters. Okay, pero gusto natin malaman kung may distinction ba yung hourly wage for white people and non-white people. May distinction ba yung hourly wage for female or non-female? So yung ganung klaseng granularity ng granularity ng analysis, we can do that if we have factors. Kaya factors play a very important role. No? They play a very important role as far as statistical analysis, in particular regression, is concerned. Okay. All right. Let's go back to our. Okay. So last time we looked at the wage data, diba? Tinignan natin we learned that pag sinabing names, ibibigay sa atin yung variables. Ito yung mga variables nga, yung head. Depende sa ilalagay natin ng number dito. Kung walang number yan, first 6 yan. Ganoon din si tail, last 6. Okay, and we use the brackets in order to subset. So wage 1 to 10 lang. Around that, yung first 10 lang ibibigay sa atin. Yeah. Okay. First 10 lang ng data natin. Hindi siya 1, 2, 3 complete. Okay, then you have structure, guys. Alam natin to, di ba? Structure, it will give us, okay, what type of data is this? This is a data frame, DF, data frame, or this is a, I think this is a table. Table is a special type of a data frame. We're going to discuss that later on. And then here we have the type of data of our variables, numeric, character. Okay. And then, pag summary naman, guys, ibibigay sa atin yung number summary per variable. Okay. So, education, yung minimum, maximum. This is your quartile 1, first quartile, second quartile, third quartile, quartile 4. Okay. And then si race, si gender, at saka si civil status, syempre, wala siyang, kasi character yan eh. Hindi naman nakakapag-compute ng number summary sa character variable. Okay, so this is just a quick review. Any questions so far, guys? Clear ba tayo so far? Paki-chat naman, please. I hope you don't mind the review, guys, kasi if you're learning R for the first time, it pays really to review the functionalities, review the codes. Okay, hindi na natin titignan yung descriptive stats na yun. Okay, so last time we also learned how to plot. Here we're just using base R plot. So pag plot natin, yung una dyan yung x-axis, yung y-axis, and then you can include several layers. Okay. In another subject, ang focus namin ngayon is data visualization. So we're learning qplot at saka yung ggplot. No? So for us guys, since hindi natin focus yun, I would really encourage you to watch videos for ggplot2. So if you have that as part of your skill set, malaking tulong yun. And in fact, I will give bonus points dun sa mga gagamit ng ggplot sa projects natin. Kasi isang project natin is of course multiple linear regression. We're going to create in an R markdown file. Of course, dapat may descriptive stat yan, dapat may plots yan, and then of course yung model, yung statistical analysis plus the analysis and the interpretation of the output. Okay, so we said here guys na hindi mag-run to kasi hindi mara-recognize ni R yung education sa R yung wage. We have to define that by this one, wage and education. Tapos dito may X label, Y label, plot character. I think I showed this to you last time, di ba? Yung plot character, sige, by way of review, let's show you this one. Yung plot character guys, iba-iba yung ano yan. Okay, 0, 1. So PCH is equal to 19, ito yun. PCH is equal to 20, ito yun, yung plot character. Okay, so we studied this last time. Okay. All right, so let's now go to simple regression. Okay, we're going to make use of the LM function. And we said that the LM function comes with the stats package, and it will run even if we don't load the stats package. Kasi pag binuksan natin yung CR and R Studio, automatically parang naka-preloaded na siya. So ma-access na natin yung mga functionalities ng stats package. Okay, maybe very quickly lang guys, since stats. Ano ba yung mga functionalities ni stats? Stats package. You can, of course, you can use the documentation from CRAN kasi maraming functionalities siya. Really a good tool for statistical analysis. Okay, so while it's loading, now we said there are 3 character variables here. And not all character variables, guys, can be used as factors. No? So titingnan nyo muna yung character ba yan, magagamit yan as classifier. No? So pag pwedeng gamitin siya as a classifier, then you convert it as a factor. O kunyari, meron kang field, meron kang variable na address. Okay, so chances are, hindi naman siya kailangan gawin yung address, hindi siya gawing factor unless na gusto mong gawing classifier kung saan nakatira yung respondents mo. Okay, so make sure to understand what a factor is. As we said, a factor is one that's used for okay, nasaan siya? So, doon na lang guys sa current na lang tingnan. Okay, so here we would like to convert si race, gender, and civil status to a factor. So we learned last week that what you do is si wage natin, wage, race, this particular variable, we're going to convert it. We still call it race, and then as that factor yung wage race. So if we run this, guys, all your factor, race, age, at si civil status, magiging ano na to. So let me run this. Run. Okay, and then if I structure na lang tingnan ko, structure ni wage. Okay, I can now see that. I see now that. Yeah, si ano na, si race, si gender, at saka si civil status, they are now factors. Okay. Alright. Now we said, guys, yung attach na ano na function. If you're only working in one data set, and then you keep on referring to the variables there, it might be a good idea to define kung anong data set yung ginagamit mo. So you use the attach package. So pag ginamit natin attach package, okay, sandali ha, hindi pa natin na-attach, di ba? So if I get the correlation between ito na muna. So if I get the correlation between education and early wage, mag-error siya. Mag-error siya. So if I attach wage, okay, and then get the correlation between education and early wage. Sabi natin, di ba makukuha na siya kasi nga naka-define na yung naka-define na lahat ng mga variables na to is coming from wage. So let's detach it again, guys. Detach ko na lang if you want to detach. Yan. And then get once again the correlation. So it will not work. Okay, so just another quick review there. Okay, punta na tayo guys ito sa regression natin. Alright. May I know guys kung anong line tayo natapos? But we were able to generate this, no? Itong names, itong coefficients, etc. Okay, I think we were able to do this last time. So, very quick review. Here we're creating an object, mod1. Okay, and we're using now LM, the LM function. The LM function is a very powerful function when it comes to regression. So the first one here should be your dependent variable, and the next one, tilde, and then the independent variable. If you're using several independent variables, then plus ka lang, plus, then plus the variable. Kunyari plus num dep, yan, and then plus whatever. Okay, but for now, let's just once again review. Data is equal to wage, and then summary mod1. Okay. So we now have, I now have mod1, and it's under my data, and it in particular, it's a list. Okay. So if I summarize it, ito yung lalabas, di ba? Yung summary function, it will first tell us yung anong formula na ginagamit. Okay, and then a summary of the coefficients. And then summarize ulit yung LM function. And then this is just descriptive statistics of the residuals. Okay, -5, yung minimum, maximum 60. Makikita natin medyo skewed to the right siya. No? Malaki yung error dun sa right side. And then the coefficients, it will tell us kung ano yung significant na parameters. Okay, this is beta null, this is beta 1, intercept is beta null, education is beta 1. Isa lang. The lone predictor, which is education, is statistically significant. Ang null hypothesis nito is beta 1 is equal to 0. So B1 is equal to 0. Yun ang null hypothesis dito sa ano natin, sa individual t-test. Okay, B1 is equal to 0. So what's our inference? Null, yung beta 1 is equal to 0. So guys, if you notice guys, I'm just reviewing kasi marami na kayong stuck subject before. So I'm just telling you that this is a regression output, and this was born about by a statistical test, hypothesis test. Ang test nun, beta null, yung intercept is equal to 0, and beta 1 is equal to 0, so education. And our inference, our conclusion is that we reject this null hypothesis. There's a strong statistical reason to believe that beta 1 or education is a value other than 0. Okay? Ang value niya dito, yung estimate niya, mean 0.54. Okay, and then you have here yung ANOVA natin, yung analysis of variance. You have F statistics 103.4, On degree of freedom is equal to 1, degree of freedom 2 is equal to 524. Okay, the p-value is practically 0. So guys, hindi na natin i-discuss in greater detail to. Ang assumption ko guys, alam niyo na itong interpretation nito ng ANOVA. So kindly review guys. Ito na lang titingnan natin yung multiple R squared at saka adjusted R squared. The R squared guys, or the coefficient of variation, that's the coefficient of variation yan, or R squared. R squared. Okay, may multiple R squared, may adjusted R squared. Ang mas gagamitin natin guys, adjusted R squared. 16.32%. What does that mean? It means guys that the 16.32% of the variability of your dependent variable HR wage can be explained by your independent variable. Okay, so 16.32% daw ng variability ng dependent variable natin na hourly wage can be explained by your independent variable education. Okay, so ano nangyari doon sa 14.68 na hindi mo na-explain? Ano nangyari doon? Well, ibig sabihin nun, si education can only explain up to a limit of 16.32%. Yung iba, it could be explained by other factors or other variables. Kaya nga, it's good to do multiple linear regression kasi nagko-contribute yung mga variables yan in trying to explain your dependent variable. Kung iisa lang, then iisa lang yung ano mo, iisa lang yung predictor, then paano yung mga ibang factors na hindi kaya i-explain na yung simple linear regression natin. So, in real life, talagang madalang yung hindi talaga ginagamit yung simple linear regression. Ano lang to for theoretical purposes, for understanding what regression is. Okay, then dito meron tayong standard error, 33.378, 524 degrees of freedom. Paano nakuha yung DF1 guys? DF1 is equal to 1. Degree of freedom 2 is equal to n minus k minus 1. Okay, so please take note of this. Yung degree of freedom 1 natin sa ANOVA natin, this is a result of your analysis of variance. Ito, yung F-stat na to. No? Okay? Itong T naman dito, T-stat na to, this is the test of individual means. So pag nagre-regression tayo guys, dalawang test yan. Yung p-value na to, t-stat to, this is born out of the test of individual means. Okay? So dito, kada isang line dito, may ano yan, may null hypothesis yung sinabi ko nga, di ba? Yung null hypothesis natin dito, beta null is equal to 0. And in this case, we fail to reject the null hypothesis kasi your p-value is greater than 0.05. Diba? So, strictly speaking, dapat hindi kasama si intercept in predicting your dependent variable. But the practice has been na kahit na si intercept, kahit na si B0, beta null is not significant, sinasama pa rin natin yung sa modeling. Okay, for predictive purposes, sinasama pa rin natin siya. Pero yung mga independent variables talaga, katulad ng education, kung hindi siya significant, wala tayong model. Hindi natin pwede magamit sa education as a predictor of hourly wage. Okay, so that's the one test. Another test, guys, is the analysis of variance. Dito, guys, ang ano natin dito, beta null, ang null hypothesis natin, beta 1 is equal to 0. So sa analysis of variance yan, dito, no? Okay, so if we have several predictors, isasama pa natin dito yun. Beta 2 is equal to 0, beta 3 is equal to 0. Okay, another name for this, can you recall guys, anong pangalan dito sa ANOVA natin, sa analysis of variance? It's called your goodness of fit test. Okay. Unfortunately, guys, as much as I would want to really dive into details of this, we will run out of time, guys, if I still do that. So suffice it to say, guys, that please review your basic statistics, lalo na yung mga t-test, mga ano yung mga mga hypothesis. Kasi gagamitin yan, guys, sa paper nyo, no? You're nearing the subject man, mag-15 boost hour na kayo, o sabi, test 1, test 2. So lahat ng mga pinag-aaralan natin dito, guys, kasi you're required to do a paper, research paper. And definitely, guys, statistical analysis kayo. And oftentimes, regression yung ginagamit. Sometimes, panel data series. Tapos may mga nila na nagde-data and developmental analysis. Yung iba nag-SEM approach, etc. So, but many will do their paper using regression. Kaya dapat, guys, alam natin ito. Okay, so we'll discuss adjusted R-squared and multiple R-squared in greater detail pag pumunta tayo sa multiple linear regression. Okay, so okay, let's go here, guys. Sorry about this. Now, always, guys, kailangan pag nag-model na tayo, di ba may mod 1 na tayo, no? Saan yung mod 1 natin? So, yan. May mod 1 na tayo, model 1. Okay, sabi natin, si model 1, maraming laman yan. Hindi lang basta-basta yung result. No? You can get, if you get the what's inside model 1, ito. Yan. 9 objects to, no? May coefficients ka, may residuals, etc. And you can access the coefficients. Dito siya, no? It's an object. Ito yung coefficients niya, intercept, education, and then ito yung fitted values, yung predicted values. Now, I think last time pala, no, hindi tinignan natin coefficients, sinubukan natin i-compute yung residuals. I haven't checked, I'm sorry, guys. I'll try to, next meeting, guys, ipapakita ko sa inyo kung bakit seemingly nagkaka-error. Meron na ba siya naka-decipher ng guys? Kung bakit may discrepancy yung binibigay ni R sa atin na residuals at saka yung kinukompute natin na residuals. Okay. Anyway, we will discuss that. And then AIC, AKIK, information criteria. So this is used to compare among models. Okay, ganun din si Bayesian information criterion. The lower the AIC, the better. So let's take a look at AIC and BIC. Control Enter. Yan, 277.42.423. So kailan natin gagamitin to? Suppose we run another model, and then this model turns up, then we got the AIC ng model 2 na yon. And then if it has a lower AIC, then we say that model 2 is better than model 1 by virtue of either AIC or BIC. The rule here is that the lower the AIC, the better the model is. Of course, we can do statistical tests for that, no? Just to confirm what AIC is telling us. Okay, let's go here, guys. Residual analysis. No? So, ito, we're just plotting yung residuals at predicted values. Okay, so hindi ko na ipiprint to. Ito na lang. No? I-review mo na lang, guys, we have to print this kasi we're creating this object. Tanggalin ko na lang, guys, yung print out na to. Hindi na kailangan i-print. But here we're creating an object called res, and this contains the residuals and the fitted values of our mod 1. Control Enter. Okay, so andito na siya, no? Si res at saka si print. So available. Tingnan natin, guys, i-view natin. Okay, here are your residuals. Okay, we were trying to look at this last time. Hindi natin na-decipher. I haven't checked it yet. I'm sorry. And then here, predicted to, ito residuals, yung error terms. All right. So, dito guys, ang gagamitin natin, what we're going to do now is, we're now going to do model diagnostics. Okay, there's a very powerful package, yung Broom package, guys. Okay, so si Broom package, again, a good practice is always seek the help. Broom. No question more. Is it okay for you to share the codes? I'm not sure. Okay. Wala bang mga codes sa inyo guys? Kasi sorry kasi ang intention ko initially nun na kayo yung magra-run ng code. Saan yung wala, guys? Dito ba sa sa line 161 dito sa mga yung object ni model 1 meron? Okay. So that means I'm going too fast. Kasi dapat ang objective ko na kayo nagsusulat ng code. Okay. Sige guys, for this one, sige, I'll give you what does the object mod 1 contain. Sige, I'll give you a few seconds. Can you write this guys? Para napapractice nyo. Kasi ang nanonotice ko, dati kasi, binibigay ko na lang yung code. So medyo pag nag-exam na, since parang hindi napapractice yung pagsulat ng code, nahihirapan. So dito, in the file that I gave you, pati yung susunod guys, yung next file na binigay ko, may mga blanco doon. So I will have to remind myself that I didn't give you the code. So I will have to really give you some time. Okay? So pakisulat nito guys if dapat na-generate yun na guys si Bob 1. Thank you by the way, Ziska, for reminding me. Salamat Now, again guys, deliberate on my part to to leave blank the other codes para ita-type nyo. Tsaka besides guys, din to, naka-record din to, so ito-post rin to. So if there were some portions of the code that you missed, you can feel free to shift through the video. Tapos tingnan nyo kung saan yung okay. Okay, guys, paki-respond nga na kuha nyo na ba itong itong code chunk na to. And were you able to generate this AIC and BIC of 277 and 270? Okay, good. Thank you. Okay, meron pa dito. Sige. Maya, sige, I'll give you a few more seconds, guys. For those of you who haven't keyed in the code. Okay, thank you, Rhea. Okay. The rest, guys, paki-chat naman kung kasi parang 6 pa lang yun, 7 pa lang yung nag-chat. Ang bilis ang oras. Makakaya na. Okay lang, sige. We will not rush into things. Okay, good. Thank you. Thank you. All right. So ito, meron ba sa inyo to, guys? Paki-chat naman please kung meron to. Okay na. Sige, for this one, sige, isi-share ko to kasi medyo mahaba-haba. So, I'll share this in the chat box. Okay, para makita natin yung anong generate ng plot na yan. Okay guys, I shared in the chat box. Please copy and then write natin dito. Okay. So I hope you were able to copy it. So dito guys, pinaplot natin si education on the x-axis, si hourly wage on the y-axis. Label natin yung x-label, x-axis label, years of education. Y-axis label is hourly wage. Plot character 19, diba? Sinabi natin last time na there are different types of plot character. And then frame is equal to false. Ibig sabihin niya, pag plinat to, wala yung black frame na kasama dun sa plot. And then main, okay, main will be scatter plot of education and hourly wage. Tapos idadagdag natin, last time din, ginawa natin to axis. Axis 1 is x-axis, no? And then isi-sequence natin from 0 to 20 by increments of 5. Okay, and then isasama natin, ito yung regression line guys, AB line. Okay, so this is to generate a line. Anong line? Yung regression line, kasi LM ng hourly wage and education. Okay, so what will be generated here is a regression line. Yung regression line natin, and then may color siya. Color guys is, okay, kasi dalawang klase, no? Color at saka fill. Pag color, yung outline nila, yung fill, yung laman. Since this is just a line, so wala naman laman yung line, no? Unless kunyari kung histogram yung ginawa mo, so gusto niyo yung outline ng histogram is blue, color ang gagamitin niyo. Pero pag gusto niyo yung laman mismo ng histogram is red kunyari, then you use the fill. Fill is equal to kunyari red. Alright. Don't worry guys, magkakaroon tayo ng example ng yan, may fill na ibang color. Okay, let's plot this. Nangyari? Error in so minsan ako nagka-error. Sandali lang. Let's plot this first. Okay. Hindi ko nasama itong main. Attempt to use zero-length variable name. Why? Wage, wage education, wage, hourly wage. X. Bakit ayaw na ito? Wage. X-axis yung wage. Y-axis yung hourly wage. Yan. Minsan guys, you need to run it twice kasi minsan nagkaka-error na wala namang error. So that's a challenge sometimes if you get an error. Alright, so you take a look at this guys. Ito yung plot. Ang problema nito guys, education, years of education, tsaka hourly wage. It doesn't look like a linear relationship nila. So, may trend siya as far as the trend is concerned. Yun lang. Pero ang laki ng variation ng natin, ng data natin. Okay, let's now plot everything. Tayo. Alpha AB line. Hourly wage regress on. Okay, look ko na kung bakit. Okay, kulang ako dito. Sorry guys. I forgot here in data. Okay. Yan ang malito. So, nag-LM ako, dapat i-define ko yung data. So, pwede na to. Yan. There. Okay. So, we have here the plot of your education and your hourly wage, this is the regression line that we developed. So, makikita natin guys na grabe yung mga residuals, no? Grabe yung mga errors. That's why, not surprising, ang kaya lang i-explain ng model natin, this regression line, is 16%. Only 16%, guys. Only 16%. Okay, so, punta na tayo guys dito, no? Here. Kindly install yung Bloom package. I'm not going to install it anymore kasi na-install ko na siya. Please install and then library. I'll give you a few seconds lang. Okay, and then once you have installed it and required it, guys, let's print this. Model, we're creating an object called Model1 Diagnostic Metrics. Okay, and it's coming from the Bloom package, and then the function is augment. Okay, sabi natin guys, pwedeng hindi nyo na ilagay itong Bloom double column, pero it's also good as by way of reminder na this augment function is coming from the Bloom package. Let's run this. Okay, so ito, model.diagnostics. So 526 observations of 8 variables. Can you see guys sa data natin? 500, it's a data frame siya, 526 observations of 8 variables. Ano kaya yung 8 variables na? Sige, tingnan natin guys. So, I could have print natin. Okay, so this is what the Bloom's package give us. Number one, it's a table. It's like a data frame na table siya. It's a table, guys. So, andito yung dependent variable natin si hourly wage. Double yung, di ba, yung type of data. And then, andito si education. Andito si fitted value, yung predicted value. Andito si residual. Okay? So, meron tayong dito yung dot hat and dot sigma. I'll explain next time kung ano to. Pati yung Cook's distance, which is used for which is used for determining kung ano to, kung this variable is an influential point. This point pala is an influential point. Okay, we'll discuss next time on outliers, leverage point, at influential points. Okay, so lahat ng observations may ganyan. Okay. And then ito my ggplot tayo dito. This is just an example of how we can plot this. I think na-install nyo naman yung ggplot 2, di ba? So kailangan lang natin i-record yung ggplot 2. Do you have this guys? Sorry Do you have this code? Chat nga please kung yes or no. Malapit yung time. Incomplete. Sige. Ilagay ko na lang din. Okay. Impos inyo mo. Masyado yata marami linagay kong missing. Control C. Sige. I'm just going to chat this again. Okay. Right in library. Tapos. Okay. ggplot. And then what's the data? Ito yung data na gagamitin. Aesthetics is used to plot yung x-axis at yung y-axis. Okay. So ang ggplot kasi guys, layers siya. Kaya nga yung GG na ibig sabihin, grammar of graphics. This is a way to plot data so that you create layers upon layers. So tingnan nyo guys, nagpa-plus tayo dito. So plus, yung plus dapat guys, hindi dapat sa beginning of a line. Dapat sa ending of a line siya. G yung point. So we're going to use a G yung point. And then plus, another layer we're going to use the smooth line. Ang gagamitin yung linear model without the standard error. You don't have to understand everything now, guys. And then plus a geom segment. Ano yung plotting natin dito? Yung ipa-plot yung segment na to hanggang dulo ng education at saka hanggang dulo ng fitted value. Gawing color is equal to red, tapos may size na 0.3. Okay, if you plot this, yan. Okay, so take a look guys at this very wonderful plot. Okay, hindi natin magagawa sa Excel yan guys. So dito, plinat guys yung ito yung fitted line natin, plinat yung length or yung height from the actual to the fitted. So ito bali yung mga residuals. So bawat isa niyan guys, residual, if you square that and you add everything, that will now be your sum of the squares of your residuals. Natutunan nyo dati ng SSR. Sum of the squares of your, or SSE, yung iba, ginagamit. Sum of the squares of your error terms. So this is quite a powerful plot, no? Kasi nakikita natin dito lalo na guys, experiment nyo. Gawin nyo yung kanina, yung quadratic. Tapos subukan yung gawin yung data na to, itong plot na to. Okay, it's already time. Alright, so let me end in that now. So ito na lang guys, ito lang yata bago na gawa natin. So if you take a look at this, and okay, you'll have here partition, 2 rows and 2 columns. Yan. Okay, ito na nga yung guys, yung diagnostics. So this will plot the residuals. So constant ba yung variance ng residuals? Mukhang hindi. No? Yung residuals natin, tingnan nyo guys, over the values of X, over the values of the fitted values, lumalaki siya. Normally distributed ba yung residuals natin? Hindi rin. No? Kasi dapat kung normally distributed to, dapat malapit lang yung mga residuals natin, malapit dito sa dotted line na to. Okay, so this is also telling us about heteroscedasticity ng dalawang to. No? Okay, so next meeting guys, dito na tayo. Okay, so may I request you guys to please read through this. Okay, read through this and then ito na guys yung multiple regression na tayo. No? So sa multiple regression, tingnan nyo guys, ang gagawin natin ito na. So module 2 na tayo and then si hourly wage, regression, education, experience, tenure, race, gender, civil status, number of dependents. Ito na guys. So lahat na ng variables ng data natin na wage, i-regress natin on hourly wage. And please guys, please paki-tingnan na muna nito tapos please go through the codes. Kung wala diyan guys, sige, I'm going to send this file para dun sa mga hindi nakaka-copy ng ibang codes para complete na yung codes. Okay? All right. So thank you so much guys. 12:33. Let me stop recording.